All right. Welcome to United Astronomy Clubs of New Jersey. We have successfully completed our in person season at Jenny Jump in State Park in Hope, New Jersey. So we are now in our online only winter season. We want to thank everyone who has joined us this season and as we battled the persistent weather conditions that happened. And you guys have made a huge impact and allowed us to continue spreading the joys of science and astronomy to as many people as we can. In fact, we're now less than 40 subscribers away from 500 on YouTube and less than 30 followers away from 100 on Twitch. So, I'm going to encourage you all to check us out at uacnj.org. That is our website where you're going to find information on all our member clubs, as well as upcoming talks and various events we're doing, like in April when we are going to do an eclipse event for the big eclipse on the 8th. You can also join us on our social media, our Facebook, Instagram, and Discord. That's where you're going to find our information on what's coming up in the next week. We'll post various interesting tidbits that we have, as well as you can check out the events there. You can, as always, we are a nonprofit, so always check. You can, if you would like to support us, always hit that like and subscribe because those are free actions. And if you so desire, you can also check us out on Patreon. And with that, tonight's talk is What's Up in the November Sky with Lonny Buinis. Lonnie has been with us a very long time and been giving the What's Up series since UAC opened in 1994, when I was only 4 years old. Although he holds degrees from Stevens Institute of Technology in Physics and Computer Science, his arms got tired. He had to set them down. He since taught himself space art and animation and video, and therefore equally values practical experience. He is the only member of the International Association of Astronomical Artists, and try and say that 10 times fast, to specialize in virtual reality worlds. Lonnie has written the first interactive space ebook, which is under consideration for publication currently. His favorite color is red. Not even he knows why. And with that, here
Thank you
is
very much,
Lonnie.
Kim. I appreciate all the behind the scenes work that's done by the volunteers at UACNJ, including Kim, Chris, and many others. Jeff, especially tonight, helped me with technical issues. I'm hoping we won't have any more. And so with that, I'm going to ask, what's up in the November sky? And that's why we're here. And we're seeing in my opening picture here, one of the principal things that you can see with your naked eye, which is a technical term, this, which you have, and many of us were born with it, is one of the greatest pieces of equipment that you can use to study the sky. It's how I started, naked eye. And then I worked on my way on up to binoculars. If you look over here, we're seeing the most distant thing in the universe that you can see with the naked eye. The light from here left almost 2.5 million years ago. It's the nearest large galaxy to us. And we're going to see how to find it later with a program, a free program that you can download and install, or you can use online, or you can use on your mobile device. It's called the Andromeda Galaxy. And it's in the constellation, you'll never guess, Andromeda. This is what we show when you come to visit UACNJ, April through October, when it's not too cold, as it is now, and when we do our live talks. I do mine every first Saturday of the month, and we'll continue that through the year. On this day, November 5th, in 1572, which was a long time ago, I was only 2 years old at that point. My favorite astronomer, Tycho Brahe, saw a supernova, which showed that the old view from Aristotle, from hundreds of years before, that the heavens were unchangeable, was wrong. A new star. We now know that it was an exploded star. A supernova can give off the energy of a whole galaxy of billions of stars. Tycho Brahe was also my favorite astronomer because he lived life, let's say, fully. He actually died from partying too hard, and he had part of his nose lopped off in a duel to determine who was a better astronomer. I guess he lost that one. He was replaced with a piece of silver, so he was known as Old Silver Nose. Tycho's supernova actually showed up in the constellation Cassiopeia the W, and this is his original drawing way back from 1574. And here is the location of the supernova. Can you see it? No, it's not there anymore. What's left is an expanding cloud of gas. I just put a mark there to show you where you would find it. But you'd look for a letter W or M, depending on which way you hold your head in the sky. Tonight, Cassiopeia the Queen is on her side. And if you go outside and look tonight, you won't see her at all because it's cloudy. So I urge you to go out on a clear night. Whatever I tell you tonight is going to apply for the rest of the month. Notice the Andromeda Galaxy is nearby in the constellation of the Princess Andromeda, which looks just like a princess, right? You don't have to believe everything I say tonight. You can challenge me. The special thing about this month is we have two of everything. Very cool. Two planets, two meteor showers, two phases of the moon, principal phases of the moon, which are very important. And we're going to find out why in just a moment. So let's start with my reference, go-astronomy.com. Go-astronomy. It's a great reference. It has a calendar of the whole year, and I'm just focusing on November when we see two planets at opposition, Jupiter and Uranus. So I'm going to start there. Planets at opposition. Here's pictures made by amateur astronomers, wonderfully detailed pictures of the giant planets. Jupiter, the largest, and Uranus, about 5 times the size of Earth. These are both gas giants. Gas giants. They're made mostly of gas. Right. Mostly hydrogen gas, most plentiful substance in the universe. And Jupiter has so much of it that it just failed becoming a star. It doesn't have enough mass to turn on nuclear fusion like our sun did. So these are wonderful pictures. Christopher, amateur, good photographs made by him. He's an amateur astronomer, but has professional quality pictures. That's what these planets look like. And let's just use a free program, Celestia, which you can use on your mobile devices or laptops to simulate the sky. Let's see. I've got Celestia right there. We can move around in Celestia, around objects. We can see their orbits, and we can specify this really great solar system browser. We can go somewhere, but I'm not going to do that. What I'm going to do is go to a specific object, the sun. I'm going to go above the sun so we can look down on the solar system and see what we mean by this opposition business. I'm going to latitude 90. What's 90 on the Earth? At the pole, right? So I'd be looking down. Longitude's unimportant. I'll just pick 0. And I'm going to go 60 astronomical units, AUs. What's an AU? Astronomical unit. That's like a standard yardstick that astronomers use. So this average distance of the Earth from the sun. And there we zoom out and we see the solar system out to the orbit of Neptune. I'm going to zoom in a bit and just focus on the Earth, Jupiter, and Uranus, 2 planets that we can see in the sky tonight. Now look where things are in their orbits. Sun, Earth, Jupiter, Uranus, 3 planets on the same side of the sun in their orbits, same side. So these planets line up closest to Earth, right? So I would take, if I want to know the distance, I take the distance from the sun to Jupiter, 5 AU, minus the distance from sun to Earth, which is, audience participation is encouraged. You can put it in the chat. If you have a good question, put it in the chat. Kim can interrupt me and we can ask away. 5 minus 1 is 4 AU. Takes about more than 8 minutes for light to go 8 AU, 1 AU. So the light from Jupiter left a half hour ago. From Uranus, this is 19 minus 1, 18 times 8, a long time, several hours, a couple hours. But they're all lined up. They're in opposition, opposite the sun, visible all night long. And if I wanted to see what that would look like from the Earth, I could use a program called Stellarium, which is like a planetarium on your computer or on your cell phone or on your tablet or on your flablet. Do we have flablets yet? Do you know what a flablet is? Look it up. You're not going to find it. Nobody's defined it yet. I invented the term flablet. I'll let you think about that. If we look in the south part of the sky, we could find planets. We could find a planet Saturn, because all you have to do is go out tonight, look for the letter S, and look straight up for the word Saturn. Wait a minute. It's not going to work that way. You can, in computer programs, you can turn the cardinal points, the directions, off and on. You can turn on the labels for planets. You can zoom in and out. You get information. Can't do that in the real sky. Saturn is low in the south. And if you look over, as I did last night, toward the east, the brilliant planet Jupiter, to me, it looked like the planet Venus. It was so bright, incredibly bright. If we could zoom into Jupiter with a telescope, a small one, we would see that Jupiter has 4 bright, large satellites, moons, discovered 400 years ago, 413 years ago by Galileo Galilei. And he, in his crude telescope, noticed Jupiter had a flattened disk with some features very hard to make out in a small instrument like Galileo's. Current small instruments are better than what Galileo had. You can actually see some of the equatorial bands, the cloud bands on Jupiter. You can see great detail with a medium-sized telescope, and lots of detail in the kinds of telescopes you would see when you come to visit UACNJ in Hope. We'll talk about this later. Jupiter, and if we want to find the planet Uranus, that's in the same part of the sky. There it is. See it? Uranus is barely visible to the naked eye, and you have to have a very dark sky, like the kind of sky we get sometimes at UACNJ. In a small telescope, Uranus is a featureless, gray, blobby disk, kind of like floating cotton candy. You cannot see the rings of Uranus, no matter how powerful an optical telescope you have. They're very dark. We know they're there from eclipses and from pictures sent by robot space probes. Uranus is tipped over on its side. We see one of the poles facing us, and the bands are greatly tipped, the cloud bands. So if you want to find these planets tonight, they're both in the same part of the sky, low in the eastern part of the sky. So you look for the letter E, right? No, no. You have to find east. We're going to tell you how to do that in a little while. Let's go back for a second. I talked about 2 of everything. There are 2 meteor showers this month. Did you know? Very exciting. These are minor showers. The big ones are in August, the Perseids, which I talk about in You'll Never Guess What's Up in August. And then what's up in December coming up next month, I'll be talking about the Geminids. These showers have up to 20 bright meteors per hour. The Taurids early, the Leonids later. The Taurids, the meteor showers are named for where they seem to stream out from. They seem to come from a one point in the sky and stream out. And yet we know that they're the debris tracks of old comets, leaving parallel tracks, all going along straight lines together. But what do they look like they're streaming out? Odd effect. It's a perspective effect, just like railroad tracks, just like highway markers, the lane markers. They don't really meet in the distance. They look like it. It's an optical illusion. So the best way to see meteors is to lie down and use your eyes to look at as big an area of the sky as you can. The torrid meteor shower, actually, there's two sub showers from two different parts of the same stream from an old comet. The southern peak and the northern peak, we are better situated to see the northern shower, which peaks on the night of the 11th, midnight into the 12th. Best time to see meteors is when you're looking down the Earth's shadow, which is around midnight. But if you can't stay up that late, that's okay. Go out earlier. And if you miss the peak night, let's say it's cloudy or rainy, or you got busy going to a party, or you forgot, like I do, because I'm old, October 13th through December 2nd is when the shower runs. It's just that we get into the peak of the stream closer to November 11th. So don't fret if you miss it. Try again the next night, the night after. These are fairly fast-moving meteors. They streak very and disappear very quickly. They are about the size of a watermelon, a grapefruit, a peach, a grape, more like a sand grain, most of them, burning up very quickly from friction in the Earth's atmosphere. The hourly rate, unfortunately, only 5. Here where I live in Bergen County with light pollution, I will see probably 0. And earthsky.org has a lot about meteors and meteor showers and other things. There's a lot of good references. I'll be throwing these out throughout the evening. And I'll have a review at the end. So don't worry if you're not scribbling, taking notes, which no one does anymore. If you're not typing, busy typing, no, nobody does that anymore either. If you're not narrating or letting AI do it for you on your tablets or phlablets or phones or flones. What's a flone? What'd you think about that? If you missed that meteor shower, there's the Leonids from Leo, the lion. Looks just like a lion, right? Tail, head. All right, so our ancestors had really good imaginations. The radiant point, the point where things seem to stream out from one direction, is in Leo's head. Peak is November 17th, but if you miss it, just keep looking. You have through beginning or early December, although it gets weaker and weaker. This is, oh, I'm sorry, I made a mistake. The Taurids are slow, the Leonids are fast. So the Taurids, you might see a long streak. The Leonids are going to disappear in a fraction of a second. These things are moving so fast. Our Earth's atmosphere, the thickest part, if you look straight up, is about 8 kilometers or 5 miles. So if something's going 70 kilometers per second, it's going through the whole atmosphere almost instantly. That's why you see just a streak as it burns up. Zenith hourly rate, 15, that's better. Not as nice as the Geminids at 20 or more. And maybe we'll see an increase because they know from previous observations, way back, 1767, there was a peak, a big stream, and we might see a repeat of that. Now we've got 2 lunar phases in addition to 2 planets and 2 meteor showers. These are important every month. We usually have 2 every month. Sometimes we have 2 of the same, like a full moon. We had that recently. That's called a blue moon. When you have 2 full moons in a month. Why? Because the full moon takes place every about 29 and a half. For those of you who are like Spock from Star Trek, that's 29.53, Captain, days to change phases, but a month is longer, right? A month average is longer than that, more than 30 days. There's a good time to look at faint objects in the sky, according to the moon, and there's a bad time. Great time, new moon. Horrible time, full moon. The full moon just blots out everything else. And the only good thing to see when the moon is full are brighter objects like planets, double stars, bright stars, star clusters. Speaking of the moon, moongiant.com is a great resource. They have the phases of the moon. They have a lunar history, lots of good stuff, things to print out. The principal quarters here, I want to point out, there's something good to see for each lunar phase. If you like to get up at 5 and 6 in the morning when the sun is rising, you look due south and you'll see the last quarter moon, a good time to see shadows on the moon, and therefore features like craters and mountains. Why? Because the shadows pick it up, makes better contrast. The worst time to see details on the moon is full, because when you shine a light from behind you onto something, do you have any shadows? No, right? So featureless. You can see bright rays coming out of some of the craters, but that's about it. So last quarter moon, if you like to get up early, a lot of us don't, that would be early in the month, November 5th. What's today's date? Right, so that's tomorrow, but it's going to look very close to that tonight. The only problem is the last time I checked, it was cloudy. If you want to see a quarter moon at a decent hour before you go to bed, go out later in the month, November 20th, and look as the sun sets in the west, and due south will be the first quarter moon. The moon is growing or waxing, getting bigger towards full. When the moon is shrinking, it's waning. To wane means to drop down, to get lower, to get less. First quarter moon. Why is it called a quarter moon if I see half a moon? There's another half, right? The side we don't see, because the moon has locked rotation. It spins around the same rate, 27.3 days, as it goes around the Earth, 27.3 days. So why do we see the phases change in 29.5 days? That doesn't make sense. Or does it? Because don't forget, the Earth-Moon system, which is a double planet, is going around the sun. By the time the moon comes around once, we've also moved around the sun a little bit, and it throws things off. The moon has to catch up. It takes another couple of days. So good time to see faint objects. New moon, that's going to be the middle of the month on the 13th. And by the time the end of the month rolls around, forget it. You might as well just go inside and no, don't do that. Go outside, challenge yourself to find objects, even if the moon is full. You can use this wonderful calendar that lets you turn off and on phase names, illumination levels, the major phases, which I highlighted like this in blue by clicking on major phases. You can change and see what the moon looks like in the southern hemisphere if you're planning a trip to Australia or South Africa or South America. Right, there they are. The 5th, the 13th, the 20th, 27th. Pay attention, boys and girls, there'll be a test later. No, there won't. But this is one of the nice things you can get at moongiant.com. From Wikipedia, I got the names of the full moon, and there are multiple names, depending if you go back to a Boy Scout. Well, the Boy Scouts used to use this old reference beard from 1918, the deer mating, the fur pelts moon, the beaver moon, from the Farmer's Almanac, other names, the frosty moon, the dark moon. But beaver moon's very popular. It's when the beavers' coats were easier to get because you could hunt the beavers by moonlight. How cruel. What did the beavers ever do to you? And anyway, we don't even need real fur anymore, right? But this is supposedly based on the language of the Algonquin Native Americans, the beaver moon. I got my reference from skyandtelescope.org. Great reference area. They have magazines. They print a magazine. They put it online. They can charge you for it, and there's free parts. Large parts are free. Very cool. With that, why don't we take a look at some of these things as they appear in a simulated sky from that program that I used before, Stellarium. Currently in version 23.2. Recently, it was in version 0.22. How'd they go from 0 to 23? I don't know. But what I'm going to do is zoom out so that you can see Stellarium is a lot like the circular star charts that we sell, shameless plug, wink, wink, at UACNJ's gift shop. A planisphere lets you look at the sky with a piece of paper any time of the day or night, any time of the year. Planisphere. So Stellarium simulates a planisphere, and I can turn it to face north. I always like to start in the north, but unlike a planisphere, I can zoom way in to see how big some familiar objects look, like this dipper-shaped group of stars hidden partially by a tree. How annoying. Why don't we change the time? We can do that. We have amazing powers. And stellarium. I just jumped from the current time, 8:25, to 9:25. Why does it say 20:25 and 21:25? What's that? That's military time, right? Add 12. 12 plus 8 is 20. 12 plus 9 is 21, right? So stellarium is using military time, so it doesn't confuse AM and PM. So I just jumped forward to get out of the tree, and by almost 9:30, you can see all eight, yes, eight, not seven stars in the Big Dipper. 1, 2, 3, 4, 5, 6, 7, 8. In the bend of the handle is a famous optical apparent double star. I say apparent. Do these stars really move around each other held on by gravity? No, not related. Mizar is 41.7 light years away, and Alcor is almost 40. So they're not related. But there are stars in the sky that are real double stars that spin, I'm sorry, not rotate, revolve about each other, just like the Earth revolves around the sun. So I have to use my terms properly. Don't want to mislead anyone. One nice thing about stellarium is you can do something that we amateur astronomers call by the scientific term cheating. Yep. Star charts usually draw lines between stars to help you visualize the head and arms and claws of Ursa Major. Ursa Major. Astronomers have shortcut names for the stars like Alpha, the brightest, Beta would be the second brightest, Greek letters. In Ursa Major, Uma. So in fact, this constellation was named after actress Uma Thurman, right? Nope. It's a shortcut. Astronomers have three-letter abbreviations, just like the post office has two-letter zip codes, right? Or well, they have five number zip codes, lettered number codes, and then we have state codes, usually two letters. Astronomers use three letters: UMA, Alpha Ursa Major. If there's a big bear, Ursa Major, there must be a small one. If we want to find it, take the distance between these two stars, Alpha and Beta, the first and second brightest stars in the Big Bear, and go 5 times their distance apart. One, this is about 5 degrees of angle, right? In the sky, we measure angles, not distances. And you can estimate it by holding your fist at arm's length. Doesn't matter how short or tall you are, usually that's about 5 degrees. And go 5 fists, 5, 10, 15, 20, 25, and you will just miss the North Star, Polaris, which points near the Earth's pole, which is about where my arrow is. It's very close. It wasn't always, because the Earth's North Pole points different places over time. The Earth has a wobbles every 25,000 years. The actual number is 24,772, Mr. Spock. Thank you very much. But 25,000 is close enough. It's called precession. The Earth precesses like a spinning top running out of energy. But it does it very slowly so that in about 8,000 years or so, this is our pole star, Vega or Vega. Alpha Lyrae, brightest star in the Lyre. Lyra, the harp. But here's where we are now. Here's where our pole was about 5,000 years ago. Thuban in the dragon. That's when the Egyptians built the pyramids. The pyramids point north. That's where they pointed then. That's where they point now. Big Bear, Little Bear, what's this? Longest constellation in the sky. It used to be the scorpion until they cut off the claws to make the balance or scales. This is Draco or Draco, the dragon, followed closely by the king and queen, Cepheus and Cassiopeia. And these five constellations, Ursa Major, Ursa Minor, Draco, Cepheus, Cassiopeia, just circle the North Pole, round and round, round and round. never rising, never setting. So why don't we see them all day long? They're up there, right? Why don't we see them during the day? The nearest star gets in the way, right? Sun, nearest star. Once you get yourself oriented to north on a star chart, you can move over to the west to see the stars of spring disappearing, Hercules, the letter H, the triangle of three bright stars in the summer, 1, 2, 3. Remember what we called this when I was talking about the summer constellations? A big triangle seen in summer. Brilliant, absolutely brilliant, ingenious name made by amateur astronomers, the summer triangle. I would never have thought of that. With the swan, the harp, and the eagle. Looks just like a harp, a swan, and an eagle. I don't know. It does have my favorite star. Favorite double star is still visible. It's still up in the west. Go out and see it before it sets. This is 2131. That's 9:31 at night. Getting later there. But if you have a chance and you have a friend with a telescope, ask him to show you the beautiful gold and cyan star Albireo. Not well represented in color in stellarium, but in the real sky, these are striking. It's really, it'll take your breath away. It's a beautiful green blue or blue green. It's right in between. It's a color called cyan, cyan, cyan. And then this golden color, a little more orange golden than the sun would look from a great distance off. Albireo. It seems to be a double star. They're not sure, but they think they're bound by gravity, revolving about each other. Some eight, oh, I'm sorry, 386 light years away. Wow. So they must be pretty bright, giant stars to be seen that bright. I'm making my way on over towards the south where the interesting things are. Why? What do I mean by interesting? Well, here we find the signs of the zodiac. We find my sign. I'm embarrassed to admit it's a sea goat. It's half fish, half goat. Capricornus. Capricornus, the sea goat. Anybody see any sea goats lately when they went to the shore during the summer? No? No, never saw a sea goat. One of my favorite authors, Isaac Asimov, was once challenged to not a duel, but a debate with a panel of astrologers. And he said, sure, I'll debate astrologers to the end of time. He was a very good debater, excellent speaker, a famous science fiction and science writer as well, wrote over 200 books. And when he found out that his sign was the goat, the old goat, he said, no, forget it. I'm not debating a bunch of astrologers who can call me an old goat. Why do we find that the zodiac signs, like the goat, the water carrier, the fishes, Pisces, Aries, the ram, why are these important? Why do they draw out where the planets move, where the sun goes, where the moon goes? Well, the solar system is kind of flat. And so if you were to draw the Earth's orbit around the sun out into space, the ecliptic is what we call it. It would look something like this. It would pass through Sagittarius, the archer. If I go back in time to about 8:30 at night, 7:30 at night, there's the teapot, which I talked about in earlier What's Up talks, summer stars, archer, sea goat, water carrier, Aquarius, Pisces, fishes, Aries, the ram. That's where we find objects in the solar system because the solar system is flat, pretty much, except for the orbits of Mercury and Pluto and most comets and a lot of the Kuiper Belt objects. And, well, very little in the solar system is flat. But all the major planets are pretty close, flat to the Earth's orbit, not tipped too far. So it's good to know these 13 constellations, not 12, one for each month. There's 13 now, because astrologers failed to take precession, the Earth's wobble, into account. Some of my favorite things to see are this time of year. Let's make it a little more difficult. Let's remove some of these markings and look for a large square. I saw this last night. I always tell people this constellation is so big, you have to turn your head side to side to see all of it. And in fact, I tried it, and the same thing happened to me last night. As I was observing in Blairstown, I looked for this big giant square. You'll never guess what we amateur astronomers call it. Go ahead, take a guess. There's the head upside down, some of the feet. I had to move my head to see the princess riding the back of Pegasus in the Great Square. Yeah, I know, very disappointing. The big square, it's called the Great Square. You would think, wouldn't you think astronomers could come up with something? The rectilinear stellar formation, the what the flaberdasher star stellar congruence. No, Great Square. Does it look like a horse? How about now? There's the fishes. There's Aquarius, the water carrier. If you don't see this culture, the ancient Greek culture, you could turn on any one of several dozen other cultures in stellarium. Very cool. You can see different kinds of drawings, different kinds of outlines. So if you want to see the most distant thing in the universe that can be seen with the naked eye, find Alpheratz, Alpha Andromeda, Alpha Andromedae, and go 2 stars over and 2 stars up. These stars are a little faint, but if the sky is dark, you'll go 2 stars over, 2 up, and find a little Y-shaped. And right in the spokes of the Y is the Andromeda Galaxy. What did I click on? Oh no, Starlink satellite. Have anybody ever see any of these? There's a lot of them. They're a lot more easy to see in a dark sky like UACNJ's. Let's zoom in on the Andromeda Galaxy. This is the way it looks in binoculars or a small telescope. Larger telescopes start to show detail, the kind that you would see in our own Milky Way from a great distance. Andromeda happens to be tipped at an angle. It's very flat, like a pancake, but it's tipped at an angle, and so is our Milky Way seen from Andromeda. So this is pretty much what we look like from a great distance. With higher exposures, bigger aperture telescopes, we can see dust lanes hiding the light of stars behind. We can see the gas lit up, hydrogen gas lit up blue by young blue stars that burn their nuclear fuel in a fraction of a second compared to the minutes spent by stars like the sun. Actually, the sun has been burning for fuel for 5 billion years. That's 5,000 million, whereas the blue stars can burn their fuel within a few hundred to a few dozen million years, very much faster. And what's all this red color? That's older stars burning their nuclear fuel much more slowly. Red dwarf stars could last trillions of years. That's thousands of billions of years. And look, 2 satellite galaxies out of the many that go around Andromeda that collided with Andromeda. We also have 2 prominent ones called the Magellanic Clouds. And some of you who have visited the Southern Hemisphere, like Australia or South America, might have seen these little clouds detached from the Milky Way. 2.5 million years ago, the light that we see today left. But galaxies live for billions of years, so that's hardly any time at all. That's the princess Andromeda. Looks just like a princess. Not too far from her mother, Cassiopeia, the big mouth, that's what I call her, boasted that her daughter, Andromeda, was more beautiful than any of the ancient Greek goddesses, including Hera, the wife of Zeus. Oh no, that's a huge mistake. Hera had a reputation for being extremely jealous. So what did she do? She didn't just laugh it off. She had Andromeda chained to the rocks to be eaten by a sea serpent, only to be rescued by Perseus holding the head of Medusa, which froze the creature Cetus the sea serpent into stone. Quite a story. It's been out there for thousands of years. It was turned into two movies, Clash of the Titans and another one, Clash of the Titans, newer. This is, if you're looking up very high in the sky, you can see the fishes and the great square. You can find a deep sky object like a galaxy. You'll also see a very bright, well, not super bright, a leaden colored star that doesn't twinkle. This is not a star, but it is one of the planetides. The ancient Greeks called them the wanderers, planetides. You can see where the word planet comes from. If I zoom in on the planet Saturn, oh, another Starlink getting in the way. In a pair of binoculars, very hard to see the rings of Saturn. You do need some magnification, but in even the smallest of telescopes, you can see the rings the way Galileo did hundreds of years ago. He said, Saturn has ears. That's all he could tell. He could not tell it was a continuous ring of material around the planet. Cassini did, and Cassini's gap here, Cassini division, was named after Cassini. We now know that there are thousands upon thousands of gaps and billions of particles in the ring, ranging from dust size on up to kilometer size, the size of small moons, moving through the ring. Saturn, at last count, has over 162 moons. I've lost count, might be 165. It currently leads even more than Jupiter, but Jupiter's trying to catch up. A lot of the tiny moons are inside the rings, and the rings themselves are moonlets, but we don't count those millions and billions. You know, even a moderate-sized telescope, you can see a lot of detail on Saturn, cloud bands, the divisions in the rings, and the shadow of the rings on, the shadow of Saturn's disk on the rings. Giant planet, you could fit 9 Earths all the way across Saturn, 9 Earths. 8,000 miles for the Earth. Quick, what's 9 times 8? No volunteers? 72,000 miles. The ring's about 170,000 miles. And yet, even though they're that big across, they're only about 10 meters or 30 feet. 30 feet thick. Incredible. I made a model of Saturn once. I airbrushed dusty paint particles on a piece of plexiglass to show the rings. Those particles were still too thick by scale. Find Saturn tonight in what constellation? What do we mean when we say Saturn is in Aquarius, the water carrier? Is it near those stars? How far away is it? Saturn is 9 AU from Earth, 9.397 astronomical units multiplied times 8. About an hour and a quarter it took light to come from Saturn to us, an hour and a quarter. And yet, if I click on this star here, Theta Aquarii, that star is 187 light years away. 187 years it took light to get to us. An hour and a half, 187 years. That's why we measure the distance to stars in the distance that light can go in 1 year, about 6 trillion miles. That's 6 followed by 12 zeros. So the stars are much further off than anything in our solar system. And there you have it. There we have our winter sky. If we look over towards the east, and I'm working my way on west to east because the Earth rotates east to west, which makes the sky look like it goes this way. Sun, moon, all the stars rising and setting. The amateur astronomers at UACNJ have clocks on their telescopes so we can track the sky. So do come visit when we're open for live viewing April through October. Not now, too cold, but if you come there when we are open, you can bring your own telescope. If you have trouble with it, maybe we can help you. You can look through telescopes. You can see projections on the side of the observatories. A lot of fun things to do. There are other activities to do through the year, other things to see. The stars of winter are rising. And here, We're looking at the sky at 7:19. Let's go forward in time, shall we? 8:19, 9:19. Some younger members of the audience have to go to bed. I won't go too much further. We can see some things rising from winter. Taurus, the face of the bull with the horns, long horns. Taurus was kind of cut in half to make other constellations. But if you look for Taurus in the winter, I'll show you how to do it using Orion's belt, which points to two star clusters, the old star cluster in the face of the bull, the Hyades, with the bright reddish star Aldebaran, supergiant star, and this beautiful grouping that I saw last night looks like a tiny dipper. It's not a dipper at all. It's a close star cluster, the Pleiades, otherwise known as the Seven Sisters. About 400 light years away, this is a young open cluster of stars, open because they're not close to one another, the way you see them in stars that look like they're in a globe, globular cluster. This is an open cluster. And the gas from which these stars were born is still visible in long exposure photographs. Not to the eye. When you look through a telescope, you won't necessarily see the gas, not in most telescopes. And you might count more than 7 stars. 1, 2, 3, 4, 5, 6 is what I usually see. If you have sharp eyesight, you might see 7 or 8. Some people say they see 7, some 8. It's kind of hard. I generally see 6, the brighter ones. 7 sisters, fun, an open cluster. Nearby is Perseus, the hero who rescued Andromeda. Is it PC to say that a prince rescued a woman nowadays? There's a big flap about that with the Snow White Disney movie. Very interesting. I admire Perseus for his effort because he had to risk his life to cut off the head of Medusa with the winking eye. The star winks at us. It's an eclipsing binary. Every few days it dims, then it gets brighter, and it dims again, and it gets brighter. As one star eclipses the other. Algol, the eye of Medusa. Look into the eyes of Medusa and you turn to stone. Will that happen if you look at Algol? No. However, if you do look through a telescope in the dead of winter and you don't bundle up properly and you stare at Algol, you might just feel like you're turning to stone. When I was young, I used to go out in the winter and look at stuff, and wow, by the time I came indoors, I was a popsicle. Perseus, Pegasus, Cetus is down there low somewhere. Cetus the serpent. Oh no, there he is. Sorry. Right below the fishes. Sea serpent. Oh, that whole story is there. It's been in the library for 3,000 years, so you guys have no excuse not to read about Perseus and Andromeda. So what is my philosophy? What's my protocol for learning my way through the sky? I start in the north and look for the Big Dipper, Little Dipper, Big Bear, Small Bear, the dragon between the house and the queen, king and queen. That's easy. Those are circumpolar. They go round and round. I look towards the west. The Milky Way is quickly disappearing. It will appear later on, late winter. Summertime's a nice time to see the whole thing, especially from UAC and J. I work my way on over past the stars of spring setting, and I look low first for Saturn in Aquarius, the water carrier. I look a little bit higher for the fishes, see the 2 fish, and the Great Square, this big square, which is imaginatively named the Great Square. Do you think you guys could have done better? Probably. Probably. A lot of amateur astronomers, when they name things, they're in a hurry, whatever comes to mind. You can find the most distant thing in the universe using the Great Square and going 2 stars over, 2 up, and see the Andromeda Galaxy, which you can see in a dark sky with your naked eye. No optical aid necessary. You might need glasses if you can't focus distance, but no telescope, no binocular. Looks nice even in a small telescope. It's bigger than the moon, several moons across. It's pretty big. Work your way on over to Perseus the hero, look for the blinking, winking star, takes several days, and then down for the stars of winter, which I'll be talking about. And you guessed it, what's up in December? And don't forget Jupiter. And for those of you with telescopes and binoculars, you can, if you know where to look, between the Pleiades and Jupiter during this month, the planet Uranus. Uranus, number 7, Mercury, Venus, Earth, Mars 4, Jupiter 5, Saturn 6, Uranus 7. And the last of the major planets is Neptune. I believe somebody did ask me where Neptune is. If you want to find something in Stellarium, you can actually enter it like this and show me Neptune. And there it is. It's in Pisces, but it's so faint that it cannot be seen with the naked eye ever. It had to be discovered by telescope. A featureless blue disk. Neptune. Neptune's out there too. And it too is along the signs of the zodiac, just like the other planets. Well, I see that it's getting late and some of us are getting tired. Some of us old people like myself, we need to take our nap. We need to go to bed early. I go to bed at 1 in the morning. So don't do that if you want to get your beauty sleep. I do want to remind you that this is free software that I was using. Free, free, free. You can download it and install it on a laptop, on a desktop. What's a desktop? Anybody remember what a desktop is? Anybody know what a floppy disk is? Anybody know what a slide rule is? Slide rule, never heard of it. I have a cylindrical one that I can show you next time. You can, if you're shy of downloading and installing stuff, you can run the supercomputers at stellarium-web.org. You can put Stellarium on your mobile device. That's free also. You can put it on your phone. Anybody have a flexible phone yet? They make foldable phones. What's next? Flexible phones? They're working on it. Celestia is also free, celestiaproject.space, but just search for Celestia. And that is a mobile version as well. And that lets you fly into space the way I did earlier to see the orbits of the planets from above. You can also fly to the moons of planets. You can fly to a place where they'll probably build a hotel so you can see the rings of Saturn open. There are only 2 places in the solar system where you can see the rings of Saturn open. One is from the moon Iapetus, which has a tipped orbit. So it goes in and out of the plane of the rings, and they do this. Open, closed, open, closed. The only other place in the solar system is Earth. To get started in astronomy, it's not as expensive as it used to be. I know when I was younger, you had to spend at least $200 to get a telescope. Now there's a first scope for $67. Binoculars are an inexpensive way to get started because if you get bored with the sky, you can take up bird watching. I do not recommend spying on your neighbors with binoculars. That's not what they're for. The Celestron first scope on the left is about $67 to start. If you like aperture, you want to get more light to see faint objects, the most inexpensive way, or the least expensive way to do it, is with a design called Dobsonian, invented by a man named Dobson. Relatively inexpensive for the big size mirrors you can get. These are all mirror telescopes. Mirror in the bottom, the light comes in, bounces off the mirror, comes up to another little mirror, goes sideways to the eyepiece. And the little telescope is called the finder because it finds what you're looking for first. Right? So those are reflecting telescopes that are less expensive. And Celestron has a nice product, but there are many different brands, Meade and others. Some references, repeat after me, UWACNIDGE, everyone, UWACNIDGE. .org. That's the United Astronomy Clubs, an umbrella organization for a whole bunch of different clubs in New Jersey and some from our neighboring states. People who still read magazines can get Sky and Telescope or Astronomy in paper. They've been out there for decades, beautifully produced great color graphics, all kinds of great tips. If you don't like to read paper, you can subscribe online, or you can get the free portions of the sites, which are extensive. Big parts of it are free. In fact, I got some of my reference images tonight from there for free. And if you forget everything I've told you tonight, even how to contact me, who cares? Just remember space.com. Easy. Space.com has all kinds of resources about news, about what's happening in space, the search for life and science and spaceflight. So, quick review. Two planets in opposition doesn't matter. You don't have to look exactly on the third or the 13th to see the planet at its brightest. They're going to be nice and bright, easy to find all month long. Meteor showers, however, have a peak. So I recommend if you're going to look for the Taurids, do it on the 4th. If you're going to look for the Leonids, do it on the 17th. If you want to throw your hands up and say it's not worth it, my sky isn't that dark, you want to wait till the Geminids come, I'll tell you about that next month. And then the new and full moon, new in the middle, the full moon at the end. Just remember, you want to get your telescope and binoculars out to see nebulas like gas clouds, nebula, or open star clusters or globular clusters, fainter objects. You want to do that around the time the moon is new, won't be interfering. I get these schedules at go-astronomy.com. I do not work for any of these websites. I'm just mentioning these as references. But these are my sites where I do, in fact, sell something called Mars at Your Fingertips, a 3D globe of Mars that you work on any screen. You can do it with a pointing device. You can do it with your fingers on a mobile device or a touch-sensitive screen. You can zoom in and out. You can spin the planet. You can click on any one of 28 hyperlinks to get short videos narrated by my wife, Jan, who is in this picture, who I haven't paid shamelessly, who worked very hard at narrating these short, snappy videos. So you won't be bored. It's cheap. It's only $8, but large parts of it are free in the HD version. The full version is 4K video. The HD version has a limited set of the links, but it's fun. Try it out for free. And if you want to try other virtual reality planets and worlds, go to astronomyinmotion.com. That's my website. You can get more information about me there, including my email. And with that, I want to thank you very much. This is what we always show our audiences live and when we do it in person. And I want to again reiterate, as Kim will, that you can find us everywhere. Thank you for being such a good audience, and we'll take questions.
All right. Thank you so much, Lonnie. Hopefully, my volume's a little better. I was told uh, when I went silent there that I was a bit quiet. So, hopefully, I'm a little better for you guys online. Thank you for another great talk. So, we're going to get right into question and answer session since I don't have to give the safety briefing for those who came into the middle of the talk. And our first online question had to do with uh, how to become a member of UACNJ. And all the information that you're looking for that, you're going to find on our website, uacnj.org, as well as the first step, which is finding one of our member clubs to become a member of. So you'll find information on them as well. All right. So, our first question that you can actually probably answer is
That's all right. If I don't know the answer, I'll just make something up.
um, silver nosing so much different than brown nosing. Not
Yeah,
really a
he
question, but
back then, Tycho Brahe's time, they did not have plastic surgery the way we do now. So they just fashioned stuff out of wood or metal. The way that in my grandmother's time, coat hangers were wood with metal wire, no plastic. So back then, he had to mold something out of silver and stuck it on his nose. And they called him Old Silver Nose.
all right. So first first question, you were asking what the gas giants were made of, And someone said they're made up of mostly beans, cabbage, and hard boiled eggs, right?
Black beans do it for me.
uh, so one of our viewers said they think they see Jupiter over their house and they see little things around it with their naked eye or with binoc. Uh, is are the moons what they're seeing, or is it the stars that they're seeing with the naked eye?
With the naked eye, that's a very good question. With the naked eye, you will see the stars that surround Jupiter, the stars of Cetus, the sea monster. But if you have even a small pair of binoculars, 7 by 35s are common. 35 millimeter lens is about, well, it's an inch is 25.4. So, like an inch and a half, and 7 power, you'll actually be able to see the moons. I've seen them with binoculars, very close to Jupiter, which looks just like a bright star. But even in a small telescope, you can see the disk of Jupiter. You will not see the disks of the moons unless you have a very large telescope. Well, relatively large. In theory, you could see the disk of Ganymede, one of the bigger moons, with an 8-inch telescope, but that's difficult. So you're probably seeing stars near Jupiter, but it is very bright. I thought I was looking at Venus last night. It's so bright. It's amazing. Good question.
All right. Uh, what are you going to do when I finally make a Google form based test for your homework and then the homework becomes actual reality that you need to grade, Lonnie?
I'll do my best.
All right. Next question is, have you ever gone meteor hunting?
Yes, actually, when I was younger, some friends of mine from college and I would go to the Great Gorge, um, and set up. Let's see, the Great Gorge is one area. And also, one of my friends has a summer home in a nice dark area. And we would set out the lawn chairs, we get the bug spray, and we spend hours just watching meteors. But it's much better from as dark a site as you can get to. So unfortunately, you usually have to travel to see it well, but don't be discouraged. If it's modestly dark where you live, you can try it, especially in August or December. And I'll talk more about the Geminids next month.
And what about meteorite hunting?
Oh, meteorite. I've never found one,
Because I
but
have a feeling that's the question they were actually trying to
yeah,
ask.
that's an interesting endeavor. That's what people do in the Antarctic, because the meteors bury themselves, but over time they work their way on out, and ice melts, evaporates, and it leaves the meteors on the surface. So that's one place where they have found quite a bit, and some from Mars. One of the UACNJ visitors once gave me a small piece of Mars, and a type of meteorite called a shergotite. And we know shergotites from their chemical composition are identical to the kinds of rocks that are found on Mars and orbiting close to Mars.
All right. So the next question is, why is the solar system flat and it doesn't have all sorts of things in different angled orbits around the sun?
Well, now I did mention there are lots of things that do orbit at all different angles. And in fact, the Oort cloud is all angles. That's why they call it a cloud. And a lot of the objects in the Kuiper belt, the dwarf planets like Pluto, have highly tipped orbits. But the major bodies of the solar system were formed from one disk that flattened early on in the formation of the solar system as a gas cloud collapsed due to something called the law of conservation of momentum, of angular momentum. Things that spin as they collapse will tend to form in a plane, in a flat plane. It's a natural physical law. So that's why we find things in the universe like solar systems and galaxies to be fairly flat. There are exceptions, of course, because things can be thrown off by gravitational encounters. Jupiter's done this. Jupiter's actually altered the path of comets as they come close, thrown them into different kinds of orbits. And in fact, it broke up a comet in 1994, comet Schumacher-Levy, and the comet crashed into Jupiter in 9 separate pieces. The Earth is going to orbit change the orbit of the asteroid Apophis in 2029, April 13th. Don't miss it. This asteroid is coming so close to us, it's going to pass inside the orbit of our geosynchronous geostationary satellites. 20,000 miles out. It's going to come in closer than that. We know for a fact that it won't hit us, but Earth's gravity is going to alter the asteroid's orbit permanently into a slightly different one. And then it'll come back in 2036 or so. This thing is about 1,100 feet across, like 3 football fields, 3 or 4 fields. Big, it's big. You wouldn't want it colliding with the Earth. But I
All
got I
right.
got off on a tangent. Sorry, Kim.
Not a problem. And I do appreciate you giving the scale comparison because sometimes it's a lot easier to visualize something being like, well, the whole 20 questions answer is it can it fit in a bread box? um, because sometimes you don't know how big things are.
Right.
Our next question is, did astronomers even know about the Earth's wobble when making up the zodiac?
Oh, they probably did not. That was thousands of years ago, but they were very keen observers. Probably by the time of not Ptolemy, but Tycho Brahe used an astrolabe, an instrument that was so big, it was the size of a house, and he accurately measured the positions of stars and planets with just a naked eye and his instrument. It was a superb achievement. He had catalogs that were so accurate that later on his pupil Kepler determined how planets move around the sun accurately, elliptical orbits. So it was possible to do a lot, with the naked eye and careful measurement. But I would say that initially they probably did not recognize precession. You have to observe the position of the Earth's North Pole over vast amounts of time to see a slight change.
All right. This next comment is astronomers subscribe to the KISS method of naming things, where it's keep it simple.
Mm-hmm. Yep, we
Because
won't
then you don't
mention.
have to remember everything.
Right, I won't mention what the second S stands for. It's rude.
I think it was more implied most people know what the KISS method is. All right, so our next question, will Saturn eventually have its rings form into singular or solid moons and basically lose its rings?
Oh, that's a very good question. It's believed the rings are a fairly recent phenomena. Recent as in within the last few millions to tens of millions of years, and we're lucky to see them. All of the giant planets have rings. Some are just brighter than others. Saturn's being the brightest, and it might have been an icy moon that got torn apart to form them. Eventually, some things collapse because of the tidal force of Saturn upon the rings. Here, while we're talking about it, we can look at Saturn again. So eventually they may disappear, and something else might crash and might go into the Roche limit, inside the Roche limit of Jupiter or Uranus or Neptune, and form a bright ring. It's just a happy accident that we can see this now. Just like the happy accident that the moon looks to be about the same size of the sun and creates eclipses. We might be the only planet in the galaxy with intelligent life that can see eclipses with a moon that's exactly the same angular size as our sun. Maybe the only one. And that's out of a possible 10 billion intelligent civilizations in our Milky Way alone. One out of billions. It's amazing. So
All
yeah,
right.
eventually we might lose the rings of Saturn, but don't worry, it's going to be millions of years.
So I am going to ask if people in our online chat have any questions, do get those in because I am getting to the end of the list. So if you do have questions, I always want to make sure we have time to get to them. And if you happen to miss getting your question in, still put it into chat or comment it when our video gets posted, and I will do my best to answer all those questions and comments as they do come in. So, our next online question is, what breed of bull is Taurus?
What breed of bull is Taurus the bull? That's a very good question. I have no idea. None. In fact,
There's a lot of them now.
now that you brought that up, what we can do is choose, let's see, let's choose a different sky culture. Hawaiian, Greek. I don't know if it will actually show images. Nah, no, it doesn't. But it draws the constellations differently. I know that no, Maori, not Mayan. Wow, look at that. It's very different. That's not a bull. I don't know what that is. Oh, there you go. What
That is
breed of
a
bull?
something.
Not a
I
bull
don't
at
know what
all.
that is.
I have no idea. But really it's open to interpretation because you can use your imagination to make it whatever you like. Could be a spider web. I've seen some giant spiders this Halloween. Very impressive. A lot of lawns have infestations of spiders.
I found a giant spider in my bathroom the other day and I was like, no,
Yikes.
thank you. Time to get the fiance to deal with the spider in the bathroom. All right. So, our next online question is, do we share telescopes since they live kind of near UAC&J, since they don't personally own one, nor does do any of their friends? So I think I'll take this one, Lonnie. So we do have telescopes on site. One of the things to operate those telescopes would be you would need to become an observer at UAC&J. And like I said, there is a whole list of qualifications and whatnot you would need to go through to become an observer. And you would then need to become qualified on those scopes. However, if you do come up during a public night and the uh, the people in control of the weather have actually looked upon us favorably, which was rather rough this season. Apparently, someone did something to annoy them greatly. The people with the weather machine. We normally have a number of telescopes open that you can look through, at which, and we have our volunteer observers available to tell you what you're looking at, as well as if there's something you want to know more about, and it does happen to be up in the sky. A lot of times they're willing to take suggestions for, oh, yes, we can point the telescope at Jupiter. And a number of our people also bring up their personal telescopes, and many of them are happy to share the night sky with people. All right. Did you have anything to add to that, Lonnie?
Not to that. I can say that last night I was given the privilege of seeing M15 in a 50-inch telescope. And here's what it looks like. That's pretty much what it looked like. It's a globular star cluster. I mentioned these, but I didn't show people a picture of an actual globular star cluster. Stars in a glob or globe. So again, the scientific terminology, you can see how it comes about sometimes. This is in Pegasus. But I have nothing else to add. If there are other questions, I'll be happy to take them. People can always write to us, to UACNJ, or to me.
Yeah. Lonnie's an excellent resource to always reach out, and he's always been willing to help any of us along our astronomy journey. So I do encourage people to uh, get in touch with you, or you can always get in touch with us. Our contact info is on our website. Again, uacnj.org is where you'll find that. And like Lonnie had mentioned, if you check us out on our social media, our Facebook, Instagram, our Discord channel are also all great resources for you guys to answer, to ask and get answers to many of your questions that you might have. including telescope troubleshooting or recommendations. So it looks like we are to the end of our questions that are provided so far. So, once again, thank you, Lonnie, for another great talk. And thank you, everyone who has joined us online. Hopefully, our next, if we cannot find a speaker for not next Saturday, but the Saturday after that, I believe it's like the 16th or the 18th. I forget the date. Look it up on our website. If we cannot find a speaker for that particular slot, our next presentation will be the first Saturday in December, which once again, Lonnie will tell us what's up in the December sky. And with that, thank you all and have a good night.